prove that C0 times C1 plus C1 times C2 plus C2 times C3 plus so on plus Cn minus 1 times Cn equal to 2n Cn plus 1. So just like before, let's take the two equations or the two expansions 1 plus x whole to the power n and x plus 1 whole to the power n. So this is expansion of 1 plus x to the power n and x plus 1 to the power n, and if you expand them and multiply, you get this equation here. So now if you look at the question, you want to find what is C0 C1, so you got to multiply the C0 here and C1 here. If you multiply C0 and C1 here, you get x to the n minus 1. So what we need to do is compare the terms of or the coefficients of x to the power n minus 1 on both sides. So first let's start on the right hand side. On the right hand side, C0 times C1 times x to the n minus 1. So let's take different color again. So C0 times C1 x to the n minus 1 plus C1x times C2 x to the n minus 2 is C1 times C2 x times x to the power n minus 2. What is that? X times x to the n minus 2, that is x to the n minus 1. So there you go. So you have C1 times C2 x to the power n minus 1. Similarly, C2 times, the next one is C3, and C3 is x to the n minus 3, so you get x to the n minus 1 again. So C3 x to the n minus 1 plus so on plus, and here if you multiply Cn minus 1, it would have x to the n minus 1, and here Cn is a constant, so Cn minus 1 times Cn x to the n minus 1. So these are all the terms of x to the n minus 1 on the right hand side. Now let's come back to the left hand side. The left hand side is 1 plus x whole to the power 2n. So let's expand that. So 1 plus x raised to the power 2n is 2n c0 plus 2n c1x plus 2n c2 x square plus the term for x to the n minus 1 would be 2n cn minus 1 x raised to the power n minus 1 plus so on. The last one would be 2n cn, 2n c2n. So what is the term of x to the power n minus 1 here? That is 2n cn minus 1. And here if you take x to the n minus 1 as a common, you get c0 c1 times c1 c2 plus c2 c3. So let's write it down. So you get c0 c1 on the left hand side plus c1 c2 plus c2 c3 plus so on plus cn minus 1 times cn is equal to, and the term or the coefficient of x to the n minus 1 here is 2n cn minus 1. But then we need to prove 2n cn plus 1. And one of the properties of binomial coefficients says that NCR is equal to NCn minus R. Therefore, 2nCn minus 1 would be equal to 2nCn minus R is 2n minus of n minus 1. So what is 2n minus n minus 1? That is 2n minus n plus 1, right? So 2n minus n is n, so this is n plus 1. So there you go. This is nothing but 2n cn plus 1, and that is what you need to prove.